Welcome to review number 6, the scientific revolution. As we've mentioned in a previous review, much of the Greek and Roman knowledge was lost to Europeans during the Middle Ages. Europeans believed in magic and superstitions as explanations for naturally occurring events. What we're going to look at today is that transition from magic to science. One of the areas we'll talk about is alchemy. Alchemy was often practiced by some of the leading thinkers of the Middle Ages and the Renaissance. It involved using spells and magic and other devices in an attempt to control the natural world. Probably the best known thing that alchemists were involved in was trying to find a way to convert lead, a soft, heavy metal, into gold, also a soft, heavy metal. When philosophers turned their attention to the natural world, they were known as natural philosophers. And during the Renaissance, they often depended on the works of Greeks and Romans from hundreds of years earlier. At the heart of the scientific revolution, this transition from magic to science, was the application of logic and reason to investigations of the natural world. Also, the use of systematic observation and repeatable experiments to found a theory on rather than rapid assumptions. So the scientific revolution was a transformation in thinking during the 15 and 1600s that was caused by the development of scientific observation, experimentation, a willingness to question traditional opinions, and finally taking advantage of the printing press and its ability to transmit newfound knowledge quickly, easily, and inexpensively. During the scientific revolution, natural philosophers were willing to question ancient beliefs. They questioned these beliefs when what they observed didn't match the traditional explanation for that event. And they used three tools to help form new conclusions or new explanations: scientific instruments, mathematics, and experiments. In effect, this was the development of the scientific method that you should know so well from your science classes. It uses carefully conducted experiments and mathematical calculations to verify the results of experiments and allow those experiments to be successfully repeated by others. As an example of this transition from traditional belief to science, we'll take a look at what was understood about our universe. Ptolemy, a Greek philosopher, came up with what is known as the geocentric theory, geo meaning Earth, and it stated that the Earth was at the center of the universe and the sun and the planets move around the Earth. You could see this for yourself by stepping out into your backyard and just looking to the heavens and watching the sun go by and the moon go by and the stars go by on a daily basis. But Copernicus realized that what he was observing in the skies and the movement of the planets and the stars, particularly movement of the planets, did not match what he would have expected to have seen if the Earth was at the center of the universe. He instead comes up with the heliocentric theory, helio meaning sun, and states that the sun is indeed at the center of the universe and everything revolves around that. Now that idea was not well received by the church, who was very reluctant to change its views. Johann Kepler was a German mathematician who used mathematics to prove that Copernicus was indeed correct. He takes these conclusions and explains them in his laws of planetary motion. Galileo Galilei was an Italian scientist who read a book by a Dutchman about building a telescope. The book was about the optics of grinding the lenses. Galileo sees an opportunity for improvement and builds a much better, much more powerful telescope, which he uses to investigate the night sky. What he sees is the planet Jupiter with its moons circling or revolving around Jupiter. Obviously, not everything in the heavens revolved around Earth, and he felt that these observations supported Copernicus's heliocentric theory. Galileo's results drew an uproar from the church. He was called in by the Inquisition, where he was made to recant or say he was wrong, basically take it back. But years later, he republished his findings, was again brought to the Inquisition, and essentially was placed under house arrest for the rest of his life because he would not back down from his beliefs. Galileo Galilei is often referred to as the father of modern science because of his techniques and approach. Sir Isaac Newton was the rock star of the scientific revolution. As a young college student, the plague had shut down his college town, so he was back on the family farm. But he didn't waste his time there. During that year, he developed the laws of gravity, the laws of motion, and what became calculus. In later years, he writes a book called The Principles of Mathematics, which may well be the most important scientific book ever written. William Harvey's contribution to the scientific revolution sounds very straightforward and obvious to us today, but it was a breakthrough. It was understanding the function of the heart and the circulation of blood. Prior to William Harvey, the belief was that the heart stopping beating was a result of dying rather than the cause of death. And we'll conclude our review of the scientific revolution by taking a minute to talk about the Roman Inquisition. The Roman Catholic Church was very resistant to change, and as we mentioned earlier, Galileo is a really good example of this. In Galileo's case, the church had announced its vision for how the universe looked, and the heavens were a specific order. We had the sky, then the cherubs, and then the angels, and then heaven. Galileo, by using a telescope to look into the sky and reporting something different that didn't support the church's view, meant that he was questioning the church's teachings. And part of their resistance was, if we are proven wrong about this, what else about our teachings might people question? Thank you for joining us as we reviewed the scientific revolution.